Okay, today we're going to cover the double angle formulae. This can all be found in your textbook. I believe it's on page 286. So you may like to refer to it. Keep that page open as we work through these examples. All these are actually given to you in the formula sheet for your O-levels itself. Okay, now these are trigonometric identities, so actually they can be there are ways that we can re-express, right, sine 2a, cosine 2a and tangent 2a. But now for example 14, let me show you how we can actually re-express these expressions so that we can actually find certain values. So for example, sine a is equals to 4/5 and is in the second quadrant itself. So if you notice, I've already drawn the diagram for you already. So sine is opposite over hypotenuse. Then I take 5 square minus 4 square. I square root this. I get the value of 3 here by Pythagoras theorem. Notice that here at this point, we are going backwards. Hence, I label here as -3. So I already have enough, right, to form all the values here. For example, sine A is opposite over hypotenuse. Cosine A is adjacent over hypotenuse. Notice that cosine is ratio of cosine is negative in second quadrant. That's correct. Tangent A is opposite is 4 over -3. So this is also negative as well. Second quadrant, cosine and tangent are negative. I have all the values I need. I can start with sine 2a is equals to 2 sine A cosine of A. So sine A value is 4/5, cosine A value is -3/5. If you use your calculator, you find that this exact value is -24/25. Similarly, cosine of 2a. There are 3 ways that I can express cosine of 2a. If you notice inside your book itself, for the example, they use 1 minus 2 sine square of a. So what the book used is 1 minus 2 sine square of a. I have decided that I shall use another one, 2 cosine square of a minus 1, to show you that you will get the same answer. So I express this as 2 cosine square of a minus 1. So it's 2. Cosine square is -3/5 square. I got this from here. Okay, and then it's square and minus 1. If you use your calculator, you find that the value will yield -7/25. Part 3 itself, okay, I find tangent of 2a is 2 tangent a cosine of a. So 2 tangent a 1 minus tangent square of a. Where do I get tangent value? We have found it earlier already. So what we get is 2 times -4/3, okay, and 1 minus -4/3 square. So what I get is 24/7. Okay, do spend some time to attempt try 14 and we will go through the answers in 3, 2, 1, let's go. First and foremost, in try 14, we learned that sine A is 12/13 and that the angle A is in the first quadrant itself, which means that sine, cosine and tangent will all be positive. So if I were to draw the diagram there, I find that sine of A is 12/13. 13 square minus 12 square, square root. I find by Pythagoras theorem that this side is equals to 5. Notice that this side will be +5. So I write here +5 itself. So from this diagram itself, you will find that sine A is 12/13. Cosine A is 5/13. And tangent A itself is opposite over adjacent is 12/5. With these values in mind, I can start to find the rest of it. So for example, sine 2a is 2 sine A cosine A. So it's 2 sine A times cosine A down here. 120/169. Cosine of 2a, 1 minus 2 sine square A, 2 sine square A, then I get -119 over negative 169. Even if you had used a different form, you should get the same answer. For example, if you have tried cosine square A minus sine square A. So what you get is 5 over 13 square minus 12 over 13 square. And then you will find that using calculator, you will also get the same answer, negative 119 over 169. So it's okay, of any of the three paths for cosine 2a that you take, it will still lead you to the same answer for this case. In part 3, simple application of tangent 2a, I get negative 120 over 119. Example 15, prove the identity. Okay, what I'm going to do here is this. I think that I shall start, okay, from the right hand side. So what I'll do is, from the right hand side itself, what I have is cotangent x times sine of 2x. Cotangent can be re-expressed as cosine over sine, while sine 2x can be re-expressed as 2 sine x cosine x. So if you notice, we can actually eliminate sine x. So 2 times cosine x times cosine x, what I'll get is 2 cosine square of x. And okay, see for this case here, at the side here, what I'm going to write for you is this. Cosine of 2x is 2 cosine square x minus 1. That's the identity that we are given. If I re-express this, cosine 2x plus 1 is 2 cosine square x. Hence, for the last step, I can just write down cosine 2x plus 1. And it is shown. Okay, I'll cover another example first before I let you all try the try-its. Okay, so for example 16 itself, I need to show that cosine square A is 1 plus cosine of 2A. So what I can do here is this. First, I will start with cosine 2A. So if I start with cosine of 2A, I know that this cosine of 2A is 2 cosine square A minus 1. That's the identity itself. Then I add 1 to both sides of my equation. Cosine of 2A plus 1 equals to 2 cosine square of A. Then what I get is cosine square of A is cosine 2A plus 1 divided by 2. Then if I just need to rearrange them around, cosine square A and this, like this, I get cosine square A is equals to cosine 2A plus 1. Just a bit more. Down here, this is the 1. This is cosine 2A. So you get 1 plus cosine of 2A. This is shown. Now, hence show that cosine 105 is equals to that. Okay, let's go slow with this example. Do I have another space here? Yes, I do. Okay, hence. So if it's hence, you need to use this expression over here to actually help you out here. So now, how does this help me? First and foremost, we are working with A and 2A. So what I can say is, I'll let angle A equals to 105 degrees. So if A is 105, this implies that 2A is equals to 210 degrees. So if I were to start here, I will say that cosine square of A equals to 1 plus cosine 2A divided by 2. What I'm doing is, I'm just using what we have proven in part 1 itself. Then, what I will start to do here is this. I will square root my left hand side, square root my right hand side. So, I will say that cosine of A is equals to square root of 1 plus cosine of 2A over 2. Now, let's use the values. A is 105, 2A is 210. So, I will say that cosine of 105 degrees is equals to the square root of 1 plus cosine of 210 degrees divided by 2. Then what I'm going to start with is this cosine of 210. Okay, where is this 210? I draw a diagram for you to see. 90, 180, 210 is here. So A, S, T, C. So this is 210. If you remember the principal angle here, alpha will be equals to 30 degrees. So now, what is a cosine of 30 degrees? This is a special angle that you should remember. Special angle here should give you square root 3 over 2. But do not forget that since, cosine of 210 is in a third quadrant, so cosine is negative. Hence, cosine of 210 degrees is equals to negative, square root 3 over 2. Therefore, what we have here is this cosine of 105 is square root of 1 minus square root 3 over 2 divided by 2. Then I continue to simplify. What I get is 2 minus root 3 over 2 divided by 2 equals to square root of 2 minus root 3 over 4. I split up the square root symbol, so I get square root of 2 minus root 3 over square root of 4. And then what I will get is square root of 2 minus square root 3 divided by 2. Then I realized something. Cosine of 105. Cosine of 105, where does it lie? It lies in the second quadrant. Second quadrant, back here, AS. Second quadrant. Is cosine positive or negative? Actually, cosine in this case is negative in the second quadrant. So, cosine of 105, we also expect the value of cosine of 105 to be negative. So, what I'm missing is a negative symbol here, here, then I put in the negative symbol there. So my final answer is negative 2, square root of 2 minus root 3 over 2. Please try it 15 and I will show you the answers in a short moment. 3, 2, 1. Try 15. What we have done here is I start from the left hand side, so I've left out that term from the left hand side itself. So I just apply a minus b square is a square minus 2ab plus b square. So a square minus 2ab plus b square. Then what I do here is cos square x and sin square x, I group them together. Minus 2 sin x cosine x, I leave it there. If you remember from your earlier chapter, sin square x plus cosine square x is equals to 1. Hence, this term here will give you a 1. 2 sin x cos x is actually equals to sine of 2x. Hence, this term becomes sine 2x. So, I get 1 minus 2 sine x. And you can always write there that this is shown. Now we are going to work out example 17. So example 17 itself is about solving equations. So I will use one slide each, to solve for each of the part A, part B, and part C. So this might take a while, but never mind. Let's just get through this together. So for part A itself, we get sine 2x plus square root 2 cosine x equals to 0. So what I'm trying to do is to try to get a trigo term on the left hand side equals to a number, on the right hand side. However, do notice that this is sine 2x and this is cosine of x. So that poses a slight challenge, but not to worry. What I can do first is this. Sine 2x gives me 2 sine x cosine x plus square root 2 of cosine x is equals to 0. Notice that the common factor is cosine of x. So what I can do is I factorize cosine of x. I'm left with 2 sine x plus root 2. equals to 0. So cosine x equals to 0. 2 sine x plus root 2 is equals to 0. Cosine x equals 0, or 2 sine x plus root 2 equals to 0. Then what I can get is, when cosine x is 0, you get your x value is equals to 90 degrees. And your value of 270. To solve for the other side, what I get is 2 sine x is equals to negative of root 2. Sine x is negative of root 2 over 2. So my principal angle here, I will find that my principal angle is 45 degrees. Sine is negative. So if sine is negative, it's in the third quadrant. And also it will be found in the fourth quadrant itself, like this. Hence, what I can say is that my x value, my principal value will give me 45 degrees. So my x value is 180 plus 45, it gives me 225. And it also takes 360 minus 45, I get 315 degrees. Okay, I'll attempt to solve part B now. Okay, part B is this: 3 sine x plus cosine of 2x minus 2 equals to 0. Okay, slowly first. We just think about it, right? Cosine of 2x presents several ways for us to do this. I can either get it as cosine square x minus sine square x, 2 cosine square x minus 1, or 1 minus 2 sine square x. Okay, we think of it for a while. Okay, the first term itself is already 3 sine x. So I do not want the first one because I don't want to generate a cosine square x. For the second one itself, same logic here. There is already a sine x there. So why should I make cosine 2x appear as cosine square x? So the logical way for me to go about it, because of this term 3 sine x, is to choose my third option, 1 minus 2 sine square x. So if I begin there, what I'll say is 3 sine x, plus 1 minus 2 sine square x minus 2 is equals to 0. If I simplify my equation, I get 2 sine square x minus 3 sine x plus 1 is equals to 0. This is a quadratic equation. If I factorize this, what I get is 2 sine x and sine x equals to 0. So I get 2 sine x minus 1 here, minus 1 here. So I can solve for sine x is equals to half, or sine x is equals to 1. Sine x equals to half, what I have is special angle. My x value is equals to 30 degrees. However, it also can occur in my second quadrant. The sign is positive, so I get 150 degrees. Sine x equals to 1. Straight away, I know that my x value is 90 degrees. Hence, these are my 3 values of x. Part C, tangent 2x and minus cotangent x. So I'll start tangent 2x minus cotangent x. So I get 2 tangent x, 1 minus tangent square x minus cotangent x. So never mind, I'll just leave it as cotangent x first. It's equals to 0. So minus cotangent x is equals to 0. Then what I can do here is this: I multiply every term by the denominator, 1 minus tangent square x. So I get 2 tangent x minus cotangent x times 1 minus tangent square x equals to 0. So 2 tangent x minus cotangent x. Cotangent x can be re-expressed as either cosine over sine, but in this case, I'll choose to express him as 1 over tangent x times 1 minus tangent square x equals to 0. So what I get is 2 tangent x Okay, then I get 1 minus 1 over tangent x minus tangent x. Okay, how I got this was 1 over tangent x times 1 gives you 1 over tangent x. 1 over tangent x times tangent square x will just simply give you tangent x itself. So if I simplify, I multiply by tangent x throughout my equation, I get 2 tangent square x minus 1 minus tangent square x equals to 0. Simplifying, I will get, sorry, I made a mistake here, this should be plus, is plus. So I get 3 tangent square x is equals to 1. Tangent square x is equals to 1/3. Square rooting both sides, I get tangent x is plus minus square root of 1/3. So if I were to find, it will be in all 4 quadrants, and my alpha value in this case is equals to 30 degrees. Because tangent is both positive and negative, I will get all 4 quadrants, so I get 30, 150, 210 and 330 degrees. Okay, please attempt try 17. Okay, let me enlarge the font for you, and then we will start with the solutions in 3, 2, 1, let's go. Okay, for try 17 part A, so what I've done here is sine 2x minus sine x. So this sine 2x is re-expressed as 2 sine x cosine x. Factorize a common factor of sine x. So sine x is equals to 0. 2 cosine x minus 1 equals to 0. You solve, okay, you will get x is these values, and cosine x, okay, because cosine is positive, it will occur in the first quadrant and the fourth quadrant. So these are the 4 values that you will get for part A. For part B itself, cosine of 2x equals to 1 minus 3 sine x. So again, cosine of 2x, there are 3 pathways you can choose. Cosine square x minus sine square x, 2 cosine square x minus 1, or 1 minus 2 sine square x. To me, I will choose the third option because on my right hand side, I see the 3 sine x. So choosing the first option is bad because of the cosine square x. Choosing the second option is even worse because this one has no sine x. So I use the third option. If I use the third option, I will get cosine of 2x is equals to 1 minus 2 sine square x. Rearrange the equation. I factorize sine x. I can solve sine x equals to 0, generating these values. And 2 sine x minus 3 equals to 0. Okay, the value of sine x, if you remember, the amplitude of the sine curve is 1. Okay, so this maximum is 1, minimum value is negative 1. In this case, sine x is 3 over 2, is not a valid answer, so this is rejected. Okay, for part C, tangent x over 2. Okay, so tangent x over 2. Okay, let me explain this a little bit for you. So now, how we solve this is sine x. Okay, so for example, sine 2x, okay, is equals to 2 sine x cosine x. Okay, how I get x and x here is 2x over 2, 2x over 2. This 2x I divide by 2. Okay, so now if I were to use sine x, okay, equals to 2 sine, okay, what I do is I take this guy, I divide by 2. 2 sine x over 2 cosine x over 2. Hence, I will get this term over here, 2 sine x over 2 cosine x over 2. Then, what I will say is tangent x over 2 is sine x over 2 over cosine x over 2. This step, I multiply both sides by cosine x over 2. And then, what I do here is I will actually, from this step here, what we can say is sine x over 2 minus 2 sine x over 2 cosine square x over 2. Common factor is sine x over 2. So you can actually factorize sine x over 2 here. So if I factorize sine x over 2, I get sine x over 2 equals to 0. And 1 minus 2 cosine square x over 2 is equals to 0. This solution generates 0 and 2 pi. This solution here, okay, it gives me this. Square rooting both sides, I will get plus minus, which means that cosine will occur in all 4 quadrants itself. So x over 2 will give me the principal value, okay, pi over 4. And pi minus pi over 4, then I just multiply by 2 to get this value and this value. So this